Today, we are diving into a mathematical idea that is so powerful, it is literally the secret sauce behind how your music gets compressed into an MP3 file. It's called the Fourier Series, and we're going to treat it like a universal recipe for building almost any repeating pattern you can imagine.
Think about it. Our world is just full of these complex but repeating patterns, right? Like the sound wave from a guitar, the jagged line of a heartbeat on a monitor, or even the alternating current in your walls. So how could we possibly find one simple language to describe all of them?
Well, what if I told you there is a single recipe? That's exactly what a Fourier series is. It's this incredible recipe that shows how any complex, repeating wave is really just a simple mix of basic ingredients, all blended together in just the right amounts. So what are these super basic, fundamental ingredients? Well, to find out, we first need to understand the #1 rule of our kitchen. Okay, so before we can start cooking, we absolutely have to follow the main rule of the house. And that rule is our recipe only works for patterns that repeat. And in the world of math, this idea of repetition has a very specific name. It's called a periodic function. Now, all this really means is that a pattern repeats itself perfectly after a certain amount of time, or what we call its period. And the most basic, the most famous periodic functions out there are the smooth, simple sine and cosine waves. And these are our fundamental ingredients. Now, here's where it gets really clever. Like any good chef, mathematicians have found a secret that saves a ton of work. And the trick is to look for symmetry in the wave we want to build. And this shortcut comes in two main flavors. First, you've got even functions, which are a perfect mirror image of themselves around the y-axis. If your wave has this kind of symmetry, boom, your recipe will only need cosine ingredients. Then, you've got odd functions, which have a kind of rotational symmetry. If you spot this, your recipe will only need sine ingredients. This is a huge advantage. It lets us know which ingredients to just throw out before we even get started. All right, so we've got our ingredients, sines and cosines. We've got our amazing shortcut, symmetry. Now I think it's time to see the master recipe that pulls this whole thing together. So what does this master formula actually look like? How does it tell us the exact amount of each ingredient we need to add to our mix? Okay, here it is. Now, I know, at first glance it might look a little intense, but it's actually just our recipe written out in math speak. It's showing that our final wave is just 3 simple things added together: a base level, a mix of cosines, and a mix of sines. So let's break down each part. First up is that A0/2 term. This is just the foundation of our wave. It's its average value. It basically sets the overall height, kind of shifting the whole pattern up or down to get it centered just right. Think of it as the plate we're putting all the food on. The second part is our collection of cosine ingredients. That big sigma symbol, it just means add them all up. We're summing up a whole bunch of cosine waves, each one with a different frequency. And that little AN out front tells us the exact amount of each one to pour into the mix. This part of the recipe takes care of all the even symmetry we talked about. And you've probably guessed it, the third part is our collection of sine ingredients. It's just like the cosines. We add up a whole series of sine waves, and the number Bn tells us the precise amount of each one we need. This is the part of the recipe that takes care of all the odd symmetry. So, we've got our base, our cosines, and our sines. Now, let's actually put this all together and see how that amazing symmetry shortcut we learned plays out in the real world. And look at this. This table just perfectly confirms our shortcut. For an even function, like x squared, the final recipe, just like we predicted, only uses cosine terms. For an odd function, like a simple line, f of x equals x, the recipe only uses sine terms. And for a function that's neither even nor odd, like e to the x, you need the whole shebang, both sines and cosines. Our symmetry rule works perfectly. It's so cool. Now, this symmetry trick is so useful that it leads to a really clever technique. What if you only care about a function over a small little section? Well, you can essentially force it to be symmetrical just to get a much simpler recipe. This is called the half-range shortcut, and here's how this little hack works. First, you just grab the piece of the function you actually need.
Then, and this is the really clever part, you extend it, basically pretending it's either an even or an odd function. By doing that, you force the wave to be symmetrical, which means for the final step, you get a much cleaner recipe that uses only sines or only cosines. It is an incredibly useful and practical tool. So what's the big picture here? What's the main takeaway? Well, we've seen that any repeating wave has a recipe, and that recipe is made of simple sines and cosines. We learned that symmetry is the ultimate shortcut for making that recipe way simpler. And most importantly, this isn't just some abstract math. This is the bedrock of our digital world. It's how we compress images, make MP3s, and process pretty much any signal you can think of.
And that kind of leaves us with a final thought to chew on. We've seen that a really complex, messy wave can be perfectly described by just a simple list of numbers, the amounts in its recipe. We've boiled down a seemingly infinite pattern to just a few key values, so it really makes you wonder, what other complex systems in our world are just a combination of simple parts, waiting for someone to finally discover the recipe? Thanks for watching.